12 out of 30, 29.
5, 6, 7, 8, 9, 10, 11. I got 11. Am I missing someone? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. All right. So, Torrance, what's the probability out of the 29? Okay, cell phones need to be put away right now. They can wait. Torrance, what's the probability if we took all 29 students' names, put them in a bag, shook them up, pulled them out? What's the probability that's going to be a boy? 12 out of 29. Now, with probability, we do always look to see if we can simplify, just like with any fraction. Will this simplify? No. Okay, well, these have different, the word here, boy, is the event we're looking at. Event. We're looking at the event that a boy's name would be drawn. 12 is the number of favorable outcomes. Okay, in the bag with all your names in it, there are only 12 slips of paper that have a boy's name on it. Lucas, I'd appreciate it if you were writing with us. 29 are the number of total possible solutions. Bless you. Okay, so essentially the formula, actually not solutions, solutions isn't the right word, outcomes, that's a better word. Try that again. Outcomes. Probability formula is the probability of the event equals number favorable over number of possible outcomes. Okay, so I give everyone a dice, 6-sided dice, assuming it's fair. Does anyone know what it means to be a fair die? Not loaded. One of the sides isn't weighted. If you weight one of the sides, then you can always get your dice to pop up a 1 or pop up a 5, depending how you weight it. But a fair dice means all 6 sides have it's equally likely that all 6 would pop up. So they're all even. Okay, so you have 6-sided dice. What is the probability that I would roll a 3? Jamie, on a 6-sided dice, how many 3s are there? There's only 1. So what's the probability that I would roll a 3? It has to be a fraction. How many sides have a 3? Those are called favorable. There's only one favorable side. And how many possible sides are there? There you go, 1 over 6. Okay? Vanessa, what's the probability I would roll an even? 2 out of 6. Are you sure? Actually? Yeah. That's better. Because the even numbers will be 2, 4, 6. 3 out of 6. Now, does this one simplify? To what? 1 over 2. So it's actually a 50% chance that you'd roll an even, assuming it's a fair die. Now, some of you I gave some special die to. And I don't really remember who. I gave a couple here and there. So who had one over here? Okay, the blue one. Okay, this is the dark blue die. No, we're going to do Jonathan first and then we'll do you. Yeah, there's a bunch of them out there. Oh, I wanted to talk about one thing before we moved on to these. I forgot, I'm sorry. Something called a sample space. Sample space. A sample space is the set of all possibilities. Okay? On a dice, a regular die, and I don't know, we're just going to use dice. I think die is the singular version. The sample space is the set which has these squiggly braces of 1, 2, 3, 4, 5, 6. Those are all possible things that could be flip up, right? There's 6 sides. Each side has one of those values. And the sample space has a total of 6 outcomes. I should put possible. 6 possible outcomes, okay? But we have some fancy die that have different outcomes. So, back to Jonathan. He has a dark blue. The dark blue dice. Have you examined it? Do you know what's the lowest number up to what's the highest number? Ah. So his sample space, and does that every number? 1, 2, 3, 4, 5, all the way up to 30? So his sample space is 1, 2, 3, 4, dot, dot, dot. I'm not going to write all of them. You guys get the idea. 28, 29, 30. So the sample space is the set of all outcomes. But what's the total possible outcomes on his die? 30. So that would be your denominator. Right? We have some more die out there. We have a light blue one that Annabelle has. Light blue. Annabelle, have you examined it? Can you tell me the sample space in order from least to greatest? Oh, it starts at 0. Now is it going 0, 1, 2, 3, 4, 5, 6, 7, 8? Okay, so 0, 10, 20, 30, 80, 90. That was a great question. We were actually having this discussion in the math department the other day. We've decided it's even. Okay, so counting by tens. Because it includes 0, how many sides does our dice actually have? Does it have 9 sides? Actually, it has 10 sides. So there are 10 possible outcomes that can pop up. Well, if her dice had started at 10, it'd have to go to 100. Yeah, if she still had 10 sides. Okay, great. We have those 2. I think there's another one in the middle here somewhere. Okay, you have one. What color is that? Oh, the little dark blue. We have lots of blue, apparently. Little dark blue. There's other colors, I promise. Okay, what's your lowest value? What's your sample space? And it'll go 1, 2, 3, 4, all the way up to 20. So our sample space is 1, 2, 3, all the way up to 19, 20. So Ariana, how many total possible outcomes are on that die? How many sides does it have? 20. Thanks, Dave. See. All right. I swear we have different colors besides blue. There's another one. Oh, finally a new color. The green, yellow, yellow, green. All right. Can you please tell me the sample space on that die? 0 to 9. So is that the same as this one, the light blue? Is it the same as the light blue? She said it's 0 to 9. Is it the same as the light blue? It's almost the same, right? Does it have the same number of sides? 0 to 9? Yeah. The other die that, I think that one was Annabelle, the light blue. That one was just counting by tens versus yours is counting by ones, starting at 0. Okay, there's one more. Diana, yours is also green, right? But it's dark green. Dark green. What's the sample space? What? 1 through what? 12. 1, 2, 3, 11, 12. So how many total possible outcomes are on that? 12. I mean, we could go all day with these. I'm not going to write this sample space down because it would take forever. Have a deck of cards here. I'm taking out the jokers. Jokers on the table. Out. Okay. Justice. How many cards are in a standard deck of cards that don't include jokers? If the jokers are removed, how many cards are there? You don't know? Isaac, do you know? 50, you're close. 52. Maybe you've heard a 52 card pickup. That means you just fill them up and you have to pick up 52 cards. 54 with the jokers. Yeah. Okay. Shh. Now some people might be at a disadvantage to this. I was. I took a whole probability class that was required in college, a whole semester just on probability. And that was a huge disadvantage because I don't know how to gamble. So I got like problems wrong because I didn't know the existence of hands, because I think it was the straight. Does anyone know what a straight is? Or is it a flush? What's a flush? Because I still don't know these. Yeah, it must have been a flush then. What's a regular flush? Yeah. So like 2, 3, 4, 5, 6, and then you have a royal flush with the royalty, right? Okay, so to find the probability of a flush, you actually have to subtract the probability of a royal flush, because it's a different hand. But I didn't know a royal flush existed, so I got the problem wrong. Because I don't know how to gamble, so I remember, I think when I was like 14, I played poker with my sisters and we had pennies. And I think that's the only time I've ever played poker. My sister, however, it's a good thing she's quit the habit, but she is quite the gambler. She would be very good in Vegas, we'll just say that. But she's quit the habit. That's good. Okay, because it's addicting. It's very addicting. My cousin as well. He's like, once I was playing, this is my cousin, he's a couple years older than me, and he was playing nickel poker. So I played nickels, and he's like, I got so into it, we were up to, in nickels, $50 on the table, in nickels. So it's like, once I realized I had that much money on the table, I decided I need to walk away. Because he was like really addicted. He just kept going and going and going, and he just wouldn't stop. So, it's addicting. Back away. Okay, anyway. So, in case you don't know, there are 4 suits. There are 4 suits. We have hearts. What else are there? Diamonds. Those are both red. Spades and clubs are the blacks, right? And then each deck has ace for like a 1. Then it goes 2 through 10, and then we have a jack, a queen, and a king. So in total there are 13 cards per suit. So if I asked you, what's the probability that I would draw an ace? Please raise your hand if you know the probability that I would draw an ace. Madison? Yeah, there are 4 aces out of 52. Does that simplify? 2 over 26, which would then simplify to 1 out of 13, because there's actually 13 cards in each suit. If I asked you, what's the probability that I drew the ace of hearts? 1 out of 52. There's only 1 of those, so there aren't any repeats. Okay, so the whole sample space would be every card in my hand, which we're not going to write all those out because that'll take a while. There's 52 of them. Every card in my hand is the sample space. Okay, and let's do this one. This is called the complement. Let me show you. The complement can be written a few different ways. The complement can be written as not A, event A. It can be written as this tilde A. It can be written as A prime. It can be written as A to the little c. Yes, we are talking about cards. Cards. Okay, so if event A was, let's see, Alejandro, what's your favorite card? Pick one. Pick a face. What card do you want to use? Ace through king. King. Okay, if event A was drawing a king, we're going to find the probability of not A, or A complement. What's the probability of A complement? You can also see this written as probability of not A. Or you can see it written as probability of tilde A. Or you can see it written as probability of A complement. Unfortunately, all of those mean the same, and you just have to be familiar with all of them. They all represent the complement. So, Alejandro, how many kings are in the deck? What? 4. Okay, so if we're doing the complement, we want to know not A. So we want to know how many are not kings. 48. There's 52 cards. We know 4 of them are kings. So there's just a little subtraction. 52 minus 4 means 48. So the probability of the complement would be 48 out of how many cards? 52. Now that does simplify. I notice they're both even. What divides into 48 and 52? 2 does. There's a larger number. 4 does. Divide both those by 4. Raise your hand when you have the simplified form, please. Lucas? 12 over 13. So the probability of drawing a card that is not a king is 12 over 13. But the probability of drawing just a king is 1 out of 13. Which is your better bet? Drawing a king or not drawing a king? Not drawing a king. 1 out of 13 for a king. 12 out of 13 for not a king. Better odds to go with not the king. Okay, so we've done the die, we've done this. Cool. Now we're going to go on to theoretical probability versus experimental probability. But first we're going to do the experimental so you understand what an experiment is. Okay, let's write down the definition, then we'll run the experiment. I give everyone a die for the experiment. Experimental probability. Okay, an experimental probability. Let's write the official definition so I don't mess it up. Of an event measures the likelihood that the event occurs based on the actual results of an experiment. Okay, experimental probability of an event measures the likelihood that the event occurs based on the actual results of an experiment. Huh? What? Oh, thank you. Actual results of an experiment. Ooh, here's another one we do a lot. Coin flipping. What's the probability I flip a heads? 1 out of 2. Alright, pick that up, please. On your notes, we're going to draw a chart and we're going to conduct a little experiment. There are, with your normal side dice, those with 2 die, use the 6-sided because it'll be faster. I'm going to cheat. I'm going to use a real line. Okay, we need 6 columns because there's 6 sides of the die. So here's the middle. And label each of the columns one different side of the die, which is 1, 2, 3, 4, 5, 6. Now when you're conducting an experiment, just doing like 2 rows isn't going to be a good representation of what your dice can do. When you go out to, actually next year, first term of secondary math 3, the whole first term is basically statistics, and you measure well, you talk about samples and surveys, and like when a president is getting elected, do they just go and poll 5 people on the street in the whole United States? Do they just ask 5 people on the street who they're going to vote for to determine which president everyone is going to lean towards? No. They poll lots of people. So you want a large sample space. You want a large sample space, so it's good representation. Also, you wouldn't only poll people from Maine or only ask people in Utah. You'd ask people through the entire nation if that's your sample space area, right? So with our dice, we don't want to just roll it 2 times. We're going to roll it 50 times. Please do not lose the dice. Try to keep it on your desk. And what I want you to do is keep track. So say you roll a 3, you're just going to do a tick mark. And you get another 3, we're just going to do like some Roman numerals, keeping track. Okay, everyone's going to do them their own individually. 50 rolls. Please go. 50, 5-0. You can do it. 5-0. Keep track, please. Hey, don't lose the dice. Someone's already lost one. You have the that went flying. Just roll them gently. Make sure you keep track. 5-0. I'll take the special die. I'll take the special die. You have the special die as well? Does anyone else over here have a special die? Thank you. Oops, I felt someone's dice. Reach that. Uh-oh. Hardest part is just keeping it on your desk. Up to that point, yeah. Alright, so Meryl came up and gave us her rolls, so I have something to work off of. What I'd like you to do, now did you have exactly 50 rolls? Okay, so first help me with number 1. Out of 50, how many times did she roll a 1? 9 out of 50, right? Okay, and I would like you to go through and do all yours. So I have 6 out of 50 here. If you didn't do exactly 50, make sure you do it out of 53 or whatever however total number of rolls you did. Okay, on Mara's, were all of hers exactly equal? No, hers, number 3 got rolled more. Okay, by raise a hand, who rolled number 1 the most? Okay, great. Raise a hand, who rolled number 2 the most? Okay, down. Number 3 the most. Okay, number 4 the most. Ooh, 22, that's almost half. Wow. Number 5 the most. Okay, number 6 the most. Does anyone beat 22 times on one number?
25.
Really? Okay, so experimental probability is based on, as it says, the results of an experiment. So, if you were to do yours again, you would have the probability, well, I'll use Mara as an example. If Mara was to do hers again, she would expect, using that same dice, using her same rolling style, not changing anything. Because some people I know just roll by picking it up. Other people actually put it in their hand and shake. There's different rolling styles. So using her same rolling style she did, she would expect the probability of her rolling a 1 would be 9 out of 50. Because based off of her experiment. The probability of her rolling a 2 will be 6 out of 50, and etc. down the line. 3, 13 out of 50, 4, 5 out of 50, which actually we know simplifies to 1/10. Ooh, we have another one over here that simplifies. I didn't look at the ones. Oh, there's another one over there. 1/5. 6/50ths, both divisible by 2, so this would be 3/25. Okay? That, however, is different than theoretical probability. So your essential question says, explain what's the difference between experimental probability versus theoretical probability. So here's what theoretical probability is. Theoretical probability. Okay? Experimental probability is the probability that the likelihood that an event will occur based off of your experiment's results. Theoretical probability describes the likelihood of an event based off of mathematical reasoning, not off of your experiment results, based off of mathematical reasoning. So it describes the likelihood of an event based on mathematical reasoning. Okay, you guys have already told me the theoretical probability of rolling a dice. It's the theoretical probability of rolling a 1 on a 6-sided dice, 9 out of 50. No, what is it? 1 out of whatever. What is the whatever? Oh, yeah, it's actually 1 out of... No, how many sides on a dice are there? 6. That's different, because if you take a calculator and divide... here's my calculator. What's 9 divided by 50? 0.18. So this is 18% experimental probability likelihood that if she redid her experiment 18% of the time, it should come up as a 1. Versus theoretical probability, the math backs up, that should actually occur. What's 1 divided by 6? 1.6 repeating, which would then be 17%. Okay, what's the 2 for her? 3 divided by 25. What percentage would that be? 12%. But again, theoretically, it should occur 17%. Okay, what's 13 divided by 50? 26%. Theoretically, again, it should occur 17% of the time. What's 5 divided by 50, which is 1 divided by 10, which 1/10 is just 10%. Theoretically, it should have occurred more, 17% of the time. And 7 divided by 50? 0.14, which is 14%. Again, it should have occurred, theoretically, 17% of the time. And 1 divided by 5? Which is what percentage? 20%. And theoretically, it should have occurred 17%. Now, if we kept this experiment going, if we rolled the dice 1,000 times, eventually it would actually start matching 17, 17, 17, 17, 17. It will get all the extra wobbles out, and everything will start normalizing to the theoretical probabilities. But you have to have a large enough sample space in order to do that. Does that make sense? If your sample space is too small, it won't necessarily match the theoretical probability. Does that make sense? You have to roll it more. You have to have a large enough sampling size to get the theoretical probability to pop out. Okay. For our homework, we're going to do a few problems on probability. And we're also going to be doing a few I call it acuity review. I don't mean to say that. I mean SAGE review. Because our SAGE test is coming up. So It's imperative that we review what we've done at the beginning of the year. Okay, so let me bring up your homework really quick. Apparently I've gotten out of it. Always, Nemo, your dice just fell on the floor underneath your feet. Okay, from the probability section, it's page 926. We're going to do 1 through 4 and 7 through 11. Okay, on the blue packet, I'm going to give you in just a sec, the blue stage review, you need to do numbers 1 through 5. And once we get it, stage packet passed out, we probably have at least time to do at least one, if not 2 of them before you leave, and then 1 through 5 will be part of your homework. Oh, I'm like, what? This is not big enough. Here's the rest. Would everyone pass up their dice to the front of your row, please? And I will come get them, making sure I get them from everyone. Lily behind you. Uh-oh. I need to go grab one more. I'll be right back. Right, can I get 4 dice for you guys? Thank you. 5 dice. Thank you. Thank you. I need 4 dice for you guys. Thank you. 5 dice. Okay, and then do you have 5 in there? Thank you. 3. Great. Great. Lovely. Alright, so on this blue packet I just gave you, the first 5 are your homework. This is review from quarter 2. Lots to do with quadratics. Remember the quadratic formula?
Yeah.
It's negative. What is it? Yeah. Negative b. Then what? Plus or minus square root b squared minus 4ac. Then what, Torrance? All over 2a. Oh, he has a talent show, man. Torrance. Quadratic formula for you for a talent show.